Here we go, guys. Okay, so this is number 5. It's x squared minus x minus 12 over 2x squared plus 3x minus 9. And the reason you want to try to do like as many as you can is because some of them have OA, some of them don't have OA, so that's why. But one of the reasons I wanted to do them with you is to show you what I think is the easiest way to go through them. Okay, so for example, I suggest that you first get your y-intercept. Like that's the first thing you should try to do. Okay, for x-intercept, the x will always equal 0. So on the right side of the screen over here, this is where I'm going to put my answers. So the y-intercept, the x, y is just a point. I already know the x is 0. And so what I do is I just plug in that 0 into that equation. So y equals 0 squared minus 0 minus 12, 2 times 0 plus 3 times 0 minus 9. And you guys are kind of lucky. This is the hardest one out of the 5 that I've done so far. And you're like, why lucky? Well, you get the exposure to the more complicated one. Okay, so anyways, these zeros. But because of that, do stop me, do say something if something doesn't make sense to you, okay? All those just cancel out, and then you get negative 12 over negative 9. Since those they're not nice numbers that divide into each other, just use your calculator. What's 12 divided by 9? What does that equal? And it's going to be a positive because a negative divided by negative is a positive. It's going to be a decimal. 1.3 repeating. Okay, we just put it like that. We don't need all the decimals. We just need to put it. That goes right there. Okay, guys, question on the y-intercept? No? Okay. What I suggest you do next, excuse me, so second, I suggest you your oblique asymptote and your HA. Okay, so this is what we did yesterday. Bobo, Button, Betsy. Okay, I'm going to rewrite it again. X squared 12. Okay, so what do we have here? Bobo, Button, or Betsy? Betsy. Okay, they're the same, equal. Okay, so this is a Betsy problem. Okay. And if you recall, Betsy, the C stands for coefficients, and so those are these two numbers right here. Okay. And so it's 1 over 2. Okay, so my HA is located at y equals 1 over 2. Which 1 over 2, it's here a decimal, right? What's 1 over 2 in the decimal form? 0.5, right? So that one's better, I think. HA to put on the graph, because we are going to graph today. Which, by the way, also, if we know the HA is that, we also know the OA, right? What is the OA? None. Because you can't have both at the same time. Okay, so I know my y-intercept, my HA, and my OA. Okay. Questions on this part, second part? Okay, after that, thirdly, I would go to factoring. This is from Monday, 210. This is where the rest of the information comes from. And the only reason I said this one was harder is because the factoring is harder than the other ones. The other ones have easier factoring. But it's not bad, it's just they're both trinomials. Okay. So we need to factor this in order to extract info out. Just focus on one thing at a time. So like, let's just do the top. Okay. The top is just one of these where you're trying to say what number times what number multiplies to negative 21, but adds to positive 4. Okay, and some of us are faster than others, and that's okay. But who's a fast factor here? What times what multiplies to 21, but adds to 4? 7 and 3. Which one would be positive? Which one would be negative? Positive 7, negative 3. Okay. We good with that? Yes. Is it not the same one? What number are we doing? I was looking at number 7. Thank you for fixing that. My bad. But that was how you factor number 7. Number 5, right? We're doing 5, right? Thank you. This is why I confused it, because they're both, these are the only two that both of them are trinomials. Okay. All right, let's try this again. My bad, guys. So now the question is, what times 1 multiplies to 12, but adds to negative 1? 4 and 3. Which one would be negative? 4. Okay. So I think that one's fine. The bottom one is the one that worries me, the factoring, because we tend to mess that one up. But this one, remember, you have to multiply the two outside numbers. So we do negative 18 this time. And the question is different now. Is what times 1 multiplies to negative 18 but adds to 3? 6 and 3. Which one's positive? Which one's negative? Negative 3, right? Now, here, the way I taught you most of the year was to put 2x, 2x, but I've been switching that over to the fraction. So now I've had you do 2x, 2x. And I know you guys don't like that because you got used to the other way, but you can still do the other way, okay? But this one reduces by 2. 2 divides into both of those numbers, so it's 1. Right, 6 divided by 2 is 3, and 2 divided by 2 is 1. And so here's how this answer translates. X plus 3, and then this one's 2x minus 3. That was the only reason I said this one was harder, because of this factoring. So if you're good with that factoring, then we're good. Okay, question up to this point. Okay, I'm going to write this on the whiteboard eventually, and I'll leave it there Monday and Tuesday, but I'll have to take it off Wednesday. And that's, you have to remember, the stuff that cancels is your whole. The one that doesn't cancel on the top is your x-intercept. The one that doesn't cancel on the bottom is your vertical asymptote. You do have to commit that to memory. Okay, so these right here, because they canceled, that's your whole. Okay, so my whole, it's a literal whole. It's like a point. It's an x and a y. And you're solving those factors, so they're always the opposite. So instead of positive 3, it's negative 3. Okay. Now I need the y of the whole. Okay, so the whole, the y comes from the leftovers. So what you canceled, what's left over after you canceled? So x minus 4 and 2x minus 3. Right? I know that for my whole x equals negative 3. Right? So I'm going to plug in to the x's so that I can get the y. Okay. And so this would look like this. Negative 3 minus 4, 2 times negative 3 minus 3. So negative 3 minus 4 is negative 7. 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. Ugly fraction, we just divide it. Will somebody divide that for me? 7 divided by 9, please. That'll be a decimal again. 0.7 repeating. That goes there. Question on the whole, guys. It's probably, I imagine as a student, that's like the most messy part because you're having to go in and put it back in.
If we still plug it in, and we just do extra work on accident, and The ones that they cancel is
You know, I don't know, but I think based on the fact that they're the same, I think you would, but I'm not sure. We have to,
I've been doing it.
and there's still this, and it's the same thing? Yeah. Yeah, I think it should just because they still cancel, so like it's not really doing nothing. So yeah, it works. Okay, guys, real quick here, okay? The top one that doesn't cancel, that's your x-intercept. The bottom one that doesn't cancel, that's your VA. Always. Okay, always. So my x-intercept is not going to be -4, but +4. It's the opposite. So x-intercept equals 4, 0. By the way, you can have, as you'll see here in a minute, you can have multiple x-intercepts. You can have multiple vertical asymptotes. Now, what was that bottom factor? 2x minus 3. This is the bottom that didn't cancel, right? That's where your VA comes from. I think this is one of the only examples that's like this. So I set this equal to 0. And let's solve it. Usually you just do the opposite sign. But notice on this one, it's not just the opposite sign. It's not just +3 because you still have that 2x. So I have to divide by 2. So x equals 3/2, which is half of 3, 1.5. So my vertical asymptote is located at x equals 1.5. Okay. A lot of moving parts, right? A lot of stuff, but it's the whole picture, right? Everything together. Any questions so far, guys? Okay. I do promise they do get easier once you get your wheel spinning. Domain. Last part. So domain is from -infinity to +infinity, but you have to jump over your hole, more specifically the x of the hole and the vertical asymptote. Those are the two things you jump over. Okay, so can somebody tell me this so I don't have to scroll up? Well, here's my vertical asymptote. It's at 1.5. What was the x of the hole? -3? Okay. Okay, so here's the two things we need to jump over. If I'm going from left to right, which one comes first, -3 or 1.5? -3. So I jump over -3 first. And then you go to 1.5, jump over 1.5, and then you go to infinity. Okay, so again, just to be clear, you jump over the vertical asymptotes and the x's of the holes. Always. Is that clear, guys? Yeah? Okay. One thing we haven't done now, right now, if you can do this, if you can leave today and do this, what we just done, we've succeeded, okay? But I want you to be able to connect it to the graphing, even though it's okay if you don't walk away today knowing how to graph, but I just want to show you exactly. It's actually pretty simple, okay? So let's graph this together. All you have to do is put all this information on there, and then it just kind of builds itself. So for example, we have a vertical asymptote at 1.5, is that right? Is that 1.5 the vertical asymptote? Yeah, so check this out. So right here, x equals 1.5. Do we have a HA on this problem? Is this, that will save me time because I have to scroll up. No HA? Okay, no HA. Do we have x-intercepts? We do or we don't? The HA is 0.5? Okay. HA equals y equals 0.5. I don't know because I have to scroll up to see. It is 0.5? Yeah, okay. So not between 0 and 1, I have a HA. Do we have a y-intercept at the very top? That was the very first thing. So 4? Yeah, 4. So 1, 2, 3. No. That's the first thing we found. 1.3. So right here, 1.3. Yeah. What do we have x-intercepts or no? The x-intercepts 4. Okay, so 1, 2, 3, 4. And then I believe we have a hole too, right? At -3, what? 0.7. So -3, 1, 2, 3, 0.7. Remember that this is at 0.5, so 0.7 is like just right above it. So oh wait, that's a hole, right? A hole. So it'll be like this. Not shaded in because it's a hole. Okay, does everybody see where all these things came from? Does that make sense? I just put the information that we got on the graph. Can you see the graph or not? Okay, that's how you graph. Because what happens is, think about what shape could I draw on here where it can't touch this wall or this wall? The only shape possible is this one. What color could we see? It has to touch the hole. It has to touch the y-intercept. Because it can't get past those walls. Okay? On this side, it's just a reflection of that one. And that's it. Okay. So right now, guys, I don't know how to say that properly to you, but graphing, that will come to you. Like right now, if you can just extract all the data, I'll be happy if you can get all that data for today. We've succeeded with that. Question right now. Okay, so we'll stop here. So now you